What I wanted to talk to you about today was something that I slipped into a video a couple of weeks back when I was talking about tuples actually, and that was a use of the keyword default. And it's not something that's absolutely obvious or commonplace in C#, and I've had a few questions come in, so I thought I'd explain what that was all about. Now, the first thing to say about default is what we're all familiar with. It's a keyword that is used when we are dealing with switch statements. And this goes right back to the early days of C. It's in lots of languages. And so we can have something like this, for example, where I'm simply saying I've got an enum days of the week. I select a particular day, Wednesday in this case, and then I have a switch statement. And I can say if it's a couple of particular days, Saturday or Sunday, then we're going to say it's a weekend. And then here we just use the keyword default to say any other possibility, this is where we want to go through. And nothing about that, as I say, that's been around a long, long time. But what I did the other week was I wrote something like this. I wrote value tuple, and then I think I had it something like string, comma, int. And I call that VT for value tuple. And I was contrasting that with the tuple generic, which is a reference type. So the point I was making that tuple is a reference type, value tuple is a value type. And then I think I was just doing something with them. So let's just print those out. But as you can see, when I do print them out, it's got a problem with them in that they are uninitialized. And so what I needed to do, give them an initial value. Now with the tuple, because it's a reference type, that's very, very simple. I can just say that equals null because any reference type will be set to null. But obviously we can't do that with a value type. That's going to give us an error. So what I did instead, I said equals default. And that kept everything happy. And so it's this use of default in various circumstances that I wanted to show you about this week. Now, to understand what's going on here, we've got to understand a little bit about the way that values are initialized in C# if we don't specify what they're going to be. So, for example, here we've said days day equals days.Wednesday. But if I were to miss that off, then we can see it's uninitialized, and immediately the compiler is objecting that we're trying to read data that has not been initialized. And whenever you declare variables locally on the stack, like we're doing here, the compiler and the IntelliSense are extremely clever at working out whether they've been initialized or not, really regardless of how complicated your code is. So if I were to do something like this, if I were to say if, and then maybe let's have just a console.readline equals Thursday, not necessarily a very practical way of doing it, but it'll show us what's happening, and then said day equals days.Thursday, then the compiler of the IntelliSense are still not happy because it can work out there is still a possible path through there if we hadn't typed in Thursday when it's not going to be initialized. However, if we go further than that, if I put an else on there and say else day is days.Friday, then the compiler can see that there is no possible path through the code that doesn't result in day being initialized, and so it stops giving us any errors. The thing is, though, it can only do that when we're dealing with local variables, so variables like we've got day there, that are declared locally within a function on the stack. When you start having member variables of a class, then it can't quite manage that. So what I've done here, I've just put together this sum class, and we can see that it's got a private field of type int, so that's a value type, and one of type string, that's a reference type. And in this case, it doesn't leave them uninitialized and keep track of what's going on. It very definitely initializes them to particular values. In the case of an int, it will initialize it to 0. In the case of a string, or indeed any reference type, it will initialize it to null. So we can see there, we've just done a toString to print that out. So print the value of x, and then either print the value of a if it's got a value, or null if it hasn't. And so if we go to my program, and then just create one of those sum classes, so var sc equals new sum class, and then if we try to call the toString and print that out, we can see that x is 0, a is null, so it's followed those rules. It's also exactly the same if we have a struct. So here I've got a sum struct, which looks pretty much exactly the same as the sum class. I've just got y and b rather than x and a. But because it's declared as struct, this is clearly a value type, not a reference type. But we can still do the same sort of thing there. So if I go back to the program and add on to that var ss for sum struct equals new sum struct, calling the default constructor again, same sort of thing, and we'll see similar results. So y is 0, b is null. So with both class and structs, if we don't do anything special, we find that the value is initialized according to those rules. So all reference types are null, value types, int's going to be 0, double's going to be 0.0, bool is going to be false, etc., etc. Now, the next thing that we can do, though, is we can actually change the way those things are constructed. So on my sum class, I could, if I wanted to, just put a default constructor in here, and rather than having those initializations, I could initialize x to 4, and I could initialize a to wibble. And by doing that, we can see that when the default constructor is called there in the program, that we're getting those values in. Now, you might think that we could do a very similar thing with a struct, but actually we can't. So if I just steal that code from the class and pop it into the struct, and so obviously we call this sum struct, we change to y and b, but actually you can see it's complaining, and if I hover over that, it's complaining structs cannot contain explicit parameterless constructors. So we saw with both a class and a struct, if we don't do anything at all, we get a parameterless constructor for free. We can change the behavior of that with a class, but we cannot do it with a struct. The point being that because a struct may exist on the stack, it's always got to follow exactly the same rules for default construction. So a struct, the default construction has to be ints are 0, strings reference types are null, etc., etc. Whereas with a class, although that's the default behavior, we can change that by writing our own parameters constructor or default constructor, whichever way you want to call it. So that's one big difference between structs and classes. Another one that's worth noting is this. If I were to overload the constructor on the class, so if I were to say something like int x, comma, string a, and then just set those up. So this dot x equals x, this dot a equals a. Obviously what that does is provides us with a constructor that takes parameters, but also something you're probably aware of, it disables this automatically generated default constructor. So now you can see on our sum class, we don't have the default constructor and we have to create it by passing in an int and a string if we want to create it at all. We could obviously overload it and have both available, but writing your own constructor inside a class turns off this auto generation. However, once again, if we go to our struct and try to put in an overloaded constructor, so again, let's steal that, pop it in there, change the name, so we call that y and b, and y, b, b. That's again perfectly okay, but there is an important subtle difference because now, if we look at the program, it's still okay to call the default constructor. So adding an overloaded constructor on the class knocks out the auto generation of the parameterless constructor, but adding an overloaded constructor on a struct, on a value type, still leaves in the parameterless constructor because the fundamental rule is value types have to default construct in the same way. They have to set everything to 0 or false or whatever it may be. And so that's one of those quite big differences between them. In general terminology, what we can say is that every data type has a default value. And for reference types, it's very simple because the default value is always null. And for value types, it's fairly simple because it's either the built-in type for integer or bool or whatever, or if it is a struct, then it is the auto-generated default constructor, which we've just seen you can't remove, you can't change. So that's the way the rules work. Now, that's essentially what this keyword default then is doing for us. What that keyword default is saying is generate this thing in the default manner. And in fact, I could have used default in both cases here, because generate the thing in the default manner for a reference type means give it a value null. So actually saying rt equals default or rt equals null is exactly the same. When it comes to a value type, saying default comes to the same as saying call the default constructor. And that's actually the reason I did this back in that other example, because when you've got a complicated thing like a tuple, then calling the default constructor is actually quite long-winded, because I've got to say new and then put all of that lot in. And so that's going to work in the same sort of way, but it's just so much neater for me to say default. So that's why I use default. And we can see it's not essential in that case. Because we know what it's going to do, because we know in the case of a reference type it's going to give us null, in the case of a value type it's going to call the default constructor, then we could just type those things in. And certainly if it's something simple like int I, although I could say int I equals default and that would give us a value of 0, it's clearly much simpler just to give it the value 0 because we know what's going on. The circumstance where default is really useful, apart from saving me a bit of typing in the example I had there, was when we don't know whether we are actually dealing with a value type or a reference type. And the circumstances that that happens in are when we are dealing with generics. So let's actually have a practical use of this. Let's just consider us having a list we'll call ints equals new list of int, and let's just give that some values. And also, given that we've got a value type, let's have a reference type as well. So a new list of string, and give that just some values like so. And then one of the things we've got available with the extension methods, the link extension methods, I could simply say console write and then int.max to get the maximum int, or console write of strings.max. And that will give me the maximum string, which is done by alphabetical order by default. So we should see we're getting 4 and Thomas as the two we have there. But slight problem we have there is that if we have empty collections, then actually what will happen there is we get an exception raised, because max isn't really particularly meaningful on an empty collection. What is the maximum of no ints whatsoever? Now, a number of similar functions actually have a way around this. If we used a method like first, you'll find there is first and FirstOrDefault. And there's a clue in the name because we're talking about default. And the difference between them is if we just say first on an empty collection, we get an exception thrown. Whereas if we say FirstOrDefault, then we'll just get back, well, the default value that we've been talking about. So if it were a reference type on the FirstOrDefault, we'd get back null, and a value type will get back 0 in the case of int, but whatever the default value is. So we'll see there, we get 0 and then nothing at all for the null. So this is actually the sort of situation where inside there, that's going to become very helpful. Because what I'd like to do, although there isn't a max or default, let's write one to see what the real benefit of this is. So let's just do it up here. I'm going to do this as an extension method. So I'm going to say public static class extensions. And then I'm going to say public static and then this is going to be generic, so I'm going to say T, and then we're going to call this max or default, make it a generic for that T, and then it's going to be extension method for IEnumerable. So we say this IEnumerable for T. So exactly the same as you'd see if you had a look at the definition of max or first or anything like that. And we'll just call this list. And then we want the max or default. So we can do most of the work actually in the existing max. So I'm just going to say if list dot count is greater than 0, then we'll simply say return list dot max. And obviously that's going to work fine with more than 0. Then we're going to say else. And what are we going to do? Well, if T is a reference type, we can return null. If T is a value type, we want to return a default constructed T. So if I'd restricted this, if I'd said where T colon struct, insisting that T is a value type, then I could have put in return new T. So if we could limit it to one or the other, we could either put that in there, or if we had it as a class, then we could just put null in there. But we want this to work for both of them. So what I actually do, take off the where clause entirely, and I'm going to simply say default, and there's that keyword, and to start with, I'm going to say default T. Okay, so we're saying we want the default value for whatever T may be, so null if it's a reference type, or the default object if it's a value type. And so down here, we'll now find, if I change that to max or default, and then run that, then we get 0 and blank, whereas if I restore those contents to these things, then we get 4 and Thomas. So whether having a max or default is particularly useful, I'm not sure, but it certainly shows what's happening here. Now, one last tiny thing to mention here. What I've used there is something that's been around in C# for a long, long time. I think it came in when generics first came in version 2, which is what is known as the default operator, where we have to say default and then in brackets put what the default type we want is. Whereas you may have noticed down here, I didn't actually need to do that. And that's because what I'm doing here, and what I could do in my generic, is use a relatively new feature that came in C# 7.1, actually, I think, which is what is known as the default literal. And that's to say, in a context where the type can be inferred, simply say default, not say default round brackets and then the type on default. And so here it can be inferred because it knows we're returning type T, and therefore it can just work that out. So again, if we just go back to what we had before, of these things being empty, then that will still work in the same sort of way. And in fact, in almost every situation, we'll find nowadays we can just use that default literal. If I were to try and do something like this, if I were to say T val equals default and then maybe return val, well, in that case, again, because we've said val is of type T, I can infer it. The only situation I can think of where we can't really infer it is if we've put var there, in which case we do have to put T in there. Otherwise, there would be no suggestion of what the type is at all. But that's really trying to make life difficult for ourselves. So that's it for this other use of the default keyword. We've talked about a number of things. The fact that on the stack, when you've got local variables inside a method, then the compiler will keep track of initialization for you, which makes everything safe. When we are dealing with classes or dealing with structs, then we find that there are a set of rules for how things initialize. Null for reference types, or the default value for value types. And then we find finally we can get at the default value for both reference types and value types using the default keyword. We've seen down here how you can occasionally find that useful just to save you a bit of typing, but most importantly it's useful inside a generic where we don't know whether we're dealing with a value type or reference type, and so the word default is essential there. So that's it for defaults, just a tiny little language feature, but something that can really make your code much more elegant. Hope you enjoyed that. Do remember to subscribe, and I'll see you next time.